Hi, Science 10, Lesson 6 today, and this is the end of Chapter 3 and the end of Chemistry. So hang in there. We are just working with the mole calculation, and remember from last lesson that the amount of grams for a mole of any substance is the molar mass that appears on the periodic table. So 26.98 grams of aluminum would be 1 mole of aluminum. Over here, 40.08 grams of calcium would be a mole of calcium. So when we last day we're adding up the molar masses of any compound, you have to add up how many grams there are per mole for each part of your chemical formula. So you'll need that concept and need your calculator for what we're doing today. We're looking at the calculation that we use in order to find moles when we have a certain mass and we can determine the molar mass using the periodic table. That will tell me how many moles of that substance you have. So you will have to get to know this formula, which is when you're looking for the amount of moles of some compound, you're going to take the mass that's indicated and divide it by the molar mass that you add up from your periodic table. Your moles will be in moles, your mass will be in grams, and your molar mass will be in grams per mole. And in order to do the calculation, I put in some reminder about significant digits, which you may remember from our introduction chapter. But if you want to just have a quick look at this, because calculations have you determine answers in the correct number of sig digs, I'm just reminding you here that in this question there are 4 sig digs. In this one down here we can say there's 4, so zeros after numbers do count, whereas in number 9 you would see that there are 3 sig digs. So that's just a little review. I did include the answers to this page in the answer key posted on Google Classroom. On the other side, we're looking at how to round answers if you do need 3 sig digs and your answer is like 29.95. Remember, you're looking for 3 digits, so you take the first 3 and check if the next one is 5 or more. Since it is, you would round this up to 30.0. You still need 3 digits, for example. This one, you only need 2 digits. You cut it off at 2 digits and you realize the next one is not 5 or more, so you would leave that one at just an 80. Okay, just a quick review. If you'd like to check out the key, all the answers for this page will be there on Google Classroom. Going on, we are looking at how to calculate the moles given the mass. In this case, it's 25.0. And the molar mass of copper sulfate, copper 2 sulfate, I have it on the screen here, is where you add up 1 copper. You can check it up. It's 63.55. 1 sulfur, which is 32.07. And 4 oxygens. It's got an O4 there. Formula was CuSO4. So 4 oxygens would be 4 times 16. And that entirely is a 152.62. So you're taking the 25.0 and putting that mass over the added up molar mass that you took from your periodic table. Remember, you have to check what the molar mass is. I can go back and just point that out for you from the periodic table if you like. It was right here. If you check out, for example, oxygen, you can see that it was in fact 16, and it's that spot where you check molar masses each time. And once you add up those molar masses, remember that moles is calculated, they're asking for moles here, find how many moles, is calculated by mass over molar mass. So simply you take your 25.0 divided by the molar mass, you add it up, and your answer here would be in the lowest number of sig digs in the question. Now, there was only one number in our original question, and that has 3 sig digs. So your answer has to be left in 3 sig digs. The answer is 0.157 moles when you take 25.0 and divide it by 159.62. So there's how you find mass. So using this calculation, this formula, remember this is one form of it to find moles. You use mass over molar mass, but you can sometimes also be asked to find the mass, and mass would be where you multiply the other two. So you cross multiply and you realize moles times molar mass will give you mass. So that's the other calculation you can do to find the mass in this second question. You have to go moles times molar mass. Moles is given in the question. There's our N. And our molar mass of MnCl4 is what you get from the periodic table. So you take 1 manganese and 4 chlorides, you add them up, and they will add up to 196.74. You can add those up for yourself and try them out. But you multiply that by 2.5, and you will get a moles or a mass answer. So it's moles times molar mass, and you get a mass answer. Now, our lowest number in the question was only 2 digits. So this is tricky to make only 2 digits. You may have to do the scientific notation saying 491 could be written as 4.9 times 10 to the 2, and that would make it an answer in 4 digits. I don't think you'll have to be doing that for any assessments that we will be doing. We won't have that tricky of a question. This third one, how many moles in 50 grams of sodium carbonate? Remember that you need to get those Na2CO3. You need the correct formula first, and then you can actually use the calculation of N is equal to little m over big M, mass over molar mass to get the answer. So 50 was given to you, 50.0 grams was given to you. You go into your periodic table, find 2 sodiums, 1 carbon, and 3 oxygens, add up those molar masses, and they will be 105.99 grams per mole. And put that in your calculator and realize it is a 0.472 mole answer. So you were looking for moles in this one. In the last example, you were looking for the mass. So it says, how much would it weigh? So mass, the calculation now is moles times molar mass. They give you 0.0500 moles in the question. Multiply that by adding up the molar mass, same as in the last question. So it's still 105.99. And your total answer for mass now is 5.30 grams. So in this case, if you're looking for mass, it's just moles times molar mass. If you're looking for moles, it's mass over molar mass. So you just need to know how to convert that formula into the 2 different forms. And we can review that again here, that if you're looking for moles, my friends, it is mass over molar mass. That is one formula. If you're looking for mass, it is moles times molar mass. If you like to use a triangle, you can make the triangle look like this. And anytime you're looking for mass, you would say that it's moles times molar mass. If you cover up your N moles, then your answer is mass over molar mass. Rarely do you get a question where you're looking for molar mass, but that is possible. You could be asked for molar mass, and in that case, you just go mass divided by moles. Pretty much we'll only be using these two formulas, and to practice those, I will give you a few of the questions that follow the pages. In the pages that follow, I will do a few questions to practice with you right now, and then the rest of those you can use as practice pages. Okay, so if we turn to this page first, this is page 31. I just want to try one of these with you, and then the other two, I guess, you can try by yourself in that first section. And these are not difficult. I do think that as in any calculations, the more you try them out, the easier they will be to do. So you get your calculator ready and give them a solid shot, guys, so that you can be proficient at using this calculation. So in this one, I'll just do sodium sulfate first. This is number one. First thing you must remember is that you need a correct formula to start any question. So sodium sulfate, remember SO4 gives a 2 to sodium, sodium gives a 1, so there's a correct formula. To get mass, which they're asking you because they already gave you moles, to get mass, you know that your formula is going to have to be moles times molar mass. So your moles is given in the question, that is 0.234. The molar mass is something you have to add up from the periodic table. You're going to need 2 of whatever the mass is of sodium, 1 of sulfur, and 4 of oxygen. If you add those up, you are going to get 142.05 grams per mole. So that is what your molar mass is that you put into your question. You don't have to take my word for it. You can go and add those up and give it a try. Your final answer here will be 33.24 grams. We are looking for mass for these. Okay, there's one example there. In our next example, we're looking for moles of the other 3 on the bottom of your page, 31. I can try number 3 with you. This is simply potassium chloride is a KCl. So in order to add up molar mass for that, it would be 1 potassium and 1 chloride, which adds up to a molar mass of 74.55. And all you do there is when we're looking for moles, we're going to go mass divided by molar mass. So we take our mass given in the question, 83.1, divided by the calculated 74.55 molar mass, and our answer for moles is a 1.11 moles. That is a few examples on page 31. Page 32 has the one with some questions, pictures on the questions. This one, we can try one of these as well. Give you an example for maybe the question 4 here. You have to get the sodium phosphate formula first, and that would be Na. Phosphate gives a 3, and then PO4. So adding that up, I know that I'm going to be doing a moles here, and that's mass over molar mass, but I need that molar mass. So go to the periodic table. We need 3 sodiums, which will end up being 3 times 22.99. We need 1 phosphate in our question here, and that's going to be 30.97. And we need 4 oxygens, which will end up being 4 times 16. Those molar masses will add up to 163.94 grams per mole. And the mass in the question is 1,000 grams. I think it's 1,000 for this whole page. So simply, you take your mass divided by the added up molar mass, and the answer to this question ends up being 6.100 moles. You can give that a try with your calculator. These questions are all done the exact same way. They're all masses that are the same. So for every question, you're taking the exact same mass, which is 1,000 grams, and putting it over the molar mass of whatever you add up. So in the last one for water, you're going to still be doing mass of 1,000 grams, and molar mass for water, as you recall, is 1802. And so giving you a second example here, this one will end up being 54.49 moles for this mass over molar mass. Remember, we're just working basically with 2 formulas, guys, and you just have to try the different versions of that. Page 34 has, I guess I missed a page, sorry, 33 has these questions, the cream of tartar questions. In this one, as I can try this first one with you, they also have an example over here you can check out. But for this one, you are using looking for masses for the whole page. So you are given moles and you calculate molar mass. Some of these are going to take like a minute to do because you need 1 potassium, you need 1 hydrogen, you need 4 carbons, 4 more hydrogens, 6 oxygens. So you do have to add those all up. It tells you that the moles here is 0.100. And you multiply it by this molar mass that you calculate, it will be 188.19. And all you do is multiply those two numbers together, it's 18.8 grams. There are only 3 parts to these formulas, and they are not difficult to do. Give them a try. My answer key is all posted. I will pop on to page 34 to give you one example here for the sodium hydroxide. And the more of these that you try, the better you will do, guys. In the sodium hydroxide question, you see that they're looking for amount in moles, and so for this one, they give you the grams, and what you're looking for is moles. So great idea to always put down your formula first and write down your amount, what you're looking for, how much in moles will be mass over molar mass. Great idea to find out your sodium hydroxide molar mass right off the start, because you know that that's what you're going to need. And if we do that, you find that it's going to be 40 to get 1 sodium, 1 oxygen, and 1 hydrogen. You will find out that that is 40.00 grams per mole, and the mass is given in the question, 8.40 grams, and your answer will be 0.210 moles. So there's an example for page 34, and give those a try, guys. The last page, when you're doing these, you are just having to balance your formula first. So remember how to do that. I'll do B with you. You want to have 2 aluminums on both sides. So you have to go over here and give yourself 2 aluminums, which balances your aluminums. Then you want to make sure that your 3 sulfates are balanced. So we go on to the right side and say to get 3 sulfates, I need 3 on the as a coefficient for this compound, which then makes 3 ammoniums. So I go back and say, sorry, 2 times 3 ammoniums, which is 6 ammoniums. So I go over here and give 6 ammoniums, which balances my ammoniums. And then I realize I need 6 hydroxides. And when I go over here, I realize there was a typo because aluminum does give a 3. So 2 times 3 is 6 hydroxides. So keep that in mind. That was a typo. Okay. What we're looking at here is when you have 1 normally, but you are looking at how much you would need if you had 3, you're multiplying each thing by 3. So over here, instead of 6, you multiply by 3. The answer is you need 18 to balance this. 2 you multiply by 3 is going to be 6. 3 multiplied by 3 is going to be 9. Here it was said 3.0, so we want 2 sig digs. 18 is fine. 2 sig digs has to be 6.0. 2 sig digs, 9.0. So you're just making, taking a look at how you multiply the coefficients if it was not 1 mole of aluminum sulfate. If it was 3, then you just multiply it by 3 all the way through. So you guys can try this page out as well, just to finish off our chapter. And practice, practice, guys. The more you practice, the easier you will see these mole calculations are. And bye.